Silicon Chip Magazine has published a Wi-Fi controlled programmable DC load. That was quite an attractive project, I thought. So I decided to build that project. So here's the mechanical part of the building of this project. You can see what the Wi-Fi load looks like in the article. So the first thing was to procure the appropriate housing. Unfortunately, couldn't get exactly the same, but that's the housing that I got. Um, this is a photo out of the magazine, and it shows the housing and it shows the little perspex plate there, which I purchased. That was purchased from Silicon Chip. So the first step in the mechanical works was to make up the front panel. And as you can see, the front panel has got a cutout for the TFT display, plus numerous buttons and connectors, and they need to be very precisely made. So that's a look at the back of the panel, of the front panel, and that shows some of the mounting screws as well. In the magazine there is a drawing. Unfortunately, the dimensions on that drawing didn't quite work for me, and luckily I discovered that before drilling it. So here it is marked up to the dimensions that I actually need. The front panel is in the machine, solidly mounted, and we're just checking it to make sure it's actually running, it's actually parallel. So let's have a quick look at that. Yeah, that's not too bad at all. Looks like it's got a bit of a, the cut is not exactly straight. But it's certainly reasonably parallel to our x-axis. So after cutting and drilling, this is what the panel looks like. You can see the holes have been pre-drilled. They haven't been drilled to their final size. Because the material is so thin, I did that with a step drill to get to the correct size. And once that panel was all cleaned up, that's what it looks like with the elements mounted to it. Also take note that there's a number of screws that are sticking out on this side, which is necessary to mount the boards behind it. Now the next part involves the black front cover. Now that front cover is laser cut and comes pre-purchased from Silicon Chip, and it's got the holes already in it. You can see that I've just painted the cutout with white paint. It's a black cover, so once the protective film is removed, the white lettering will be left, and that's of course very nice and visually appealing. And here we're looking at the reverse side. So this is not the front where the lettering is. This is the back that meets with the metal. And I'd like to draw your attention to some of those holes that you can see there that they look black. They was not drilled through. They're done with an end mill. And the purpose of those holes is to accommodate the bolts that are coming through, that are sticking through from the mounting of the printed circuit boards behind it, and they will hide those holes so they are not, the bolts are not visible on the outside, because we have in fact two layers there. We've got the metal front, and then we've got that laser cut acrylic that's in front of it. And here's the result. Quite a nice looking front panel. You can see the white lettering that has come out, and none of the mounting screws are visible. at the front. So the next part is the heat sinks. The two heat sinks which are purchased don't have mounting holes in them, so they need to be drilled. And of course, those mounting holes need to be pretty precise because they actually hold the printed circuit boards. And as you can see, they are very close to the copper tubes that are going through there. So precision is very important, and for that purpose, again, these were actually drilled in the CNC mill, just to get everything right here and not to damage the copper tubes. You can see the standoffs. The original project has got some packers in there. I've decided to put a couple of standoffs in, hex standoffs, and that is where the printed circuit boards, the two printed circuit boards, are actually mounting to. Again, that was a bit of a tricky job just to get it right and to get it close to those copper tubes without actually damaging them. Now the next job, which is the last job, is the cutouts for the fans. Whilst this particular housing has got some slots in it, which means we don't have to drill additional holes, the air can get in, but for the fans, in order to provide unobstructed airflow, it's still necessary to make a cutout. So the tricky part in that is obviously the clamping. To get that clamped, I've decided to do that in the mill as well, and here's a little bit about how that was clamped.
Machining the housing for the DC load. That's a very different way of clamping. In order to get the housing in, you can see the marked positions there, and we've got a big piece of timber which is clamped to the table, and then we've got these clamps on here, two of them which are holding the actual piece of metal, and we'll be using a 4mm cutter. We'll see how that goes.
So the cutting went quite all right. As you can see, it was pretty straightforward. There's a couple of bits that decided to bend upwards a little bit, but that's okay. That didn't really make any difference. It just needs a bit of cleaning up. Obviously, there's a fair bit of burr on it, so with a little bit of patience and 10 minutes time, we'll have that cleaned up and looking the part. So after the cleanup, it actually looks quite alright. We can see the holes are 85mm, so that's pretty much exactly at the diameter of the fan blade, and it comes up quite nice. I've left out the holes that in the project there's holes on the bottom of the enclosure, but I've left them out because we've got those screws, the grill on the other side, so that should be sufficient to suck in enough air. Alright, that's the fans. The last little job is to drill a hole in the back panel for the power supply, and that's it. That is it. That's all the drilling done and ready to assemble. Okay, so here's a few photos of the inside. There we can see the cooling fins and what it all looks like. That's the front panel. You can see the connectors down the bottom. Here's a bit of a detailed look at the connectors. That's from the top, the two printed circuit boards with the MOSFETs. And here we have got a bit more detail. You can see the copper tubes underneath. That's where those MOSFETs are mounted. That's what the fans look like. That photo shows the boards and the top of the fans. I've left some of the paper on those fans. And here's is a photo of the whole side that shows how those fans are sitting in there and how they are mounted. We've also got a photo of the relay. That's that photo here. So there's the relay that actually physically disconnects the output when the load is switched off. So yeah, there we go. That's pretty much what's happening on the inside now. The whole box assembled. Looks quite nice, came up quite well. You'll notice one thing that is different to the silicon chip project. That's the little antenna at the front. I've decided to use a slightly different ESP32 board, which has got an external Wi-Fi connection, and I've brought out the Wi-Fi antenna to the outside. I thought having the inbuilt Wi-Fi antenna that's on the ESP32 board is probably not so good if I've got a metal box and my Wi-Fi isn't that good. So there we go. That's the mechanical work on the DC light done. A very nice project, and has got lots and lots of new features, and they're great features too. So thank you to Silicon Chip and Richard Palmer for publishing the project, and thank you for watching my video.